Imagine waking up on a normal morning and seeing on your phone a news story no one ever wanted to read. An asteroid the size of a stadium is headed toward Earth. An impact will happen in just 2 weeks. This isn't a science fiction film, nor a conspiracy rumor. It's the reality most feared by generations of scientists and governments. In seconds, everyday life loses its meaning. Work, traffic, commitments, everything becomes irrelevant in the face of the countdown to the end. This asteroid, while not the largest, travels faster than any missile ever created, shining in space like a second star. If it hits Earth, it will release energy equivalent to thousands of nuclear bombs, destroying entire cities, kicking up enough dust to blot out the sun for months and plunging the planet into a global winter. The question that echoes is simple and terrifying. What could humanity do in just 14 days? This isn't as far-fetched a hypothesis as it seems. We've already discovered enormous cosmic rocks when it was too late to react. In 2019, for example, the asteroid nicknamed OK passed closer to us than some satellites and was only identified a day before. 1 day. Now imagine if it were on a collision course. There wouldn't even be time to discuss the matter. Another case, in 2020, a gigantic comet was detected just 4 months before its closest approach. If this object had come straight toward us, there wouldn't be any technology ready to save us. It's precisely in this last-minute scenario that fear mixes with urgency. The mind's first reaction is to think of nuclear bombs. After all, they are the most destructive weapons we've ever created. It would be logical to believe that if we exploded an atomic device against an asteroid, we could shatter it into pieces and rid ourselves of danger. But this idea, so prevalent in movies, falls apart in the face of reality. Exploding a bomb in space doesn't create the shockwave we see in Hollywood scenes, because there's no air to transmit the pressure. Most of the energy is lost. And even if the bomb hit its target, the asteroid would continue on almost the same path, just shifted a few kilometers. The problem is that a few kilometers of deviation means nothing on a planetary scale. The impact would have happened anyway. Another alternative that has already been studied is to install engines or rockets on the asteroid, slowly attempting to change its trajectory. It sounds ingenious, but it faces 2 obstacles. First, it's virtually impossible to land on an object traveling tens of thousands of kilometers per hour. Second, even if it were possible, the process of diverting such a massive body would take years or decades. And in our scenario, we only have 2 weeks. It's like trying to nudge a cargo ship with a toothpick, hoping it will change course in time. So what's left? This is where a less glamorous but far more promising idea comes in: using the asteroid's own velocity against it. Instead of external explosions, scientists have begun proposing the use of penetrators, ultra-dense projectiles made of metals like tungsten. They don't require engines or sophisticated explosives. Simply position them in the right direction and leave them motionless. For the asteroid, traveling at tens of thousands of kilometers per hour, this stationary object becomes a lethal missile. The impact generates heat, melts rocks, and opens craters, spreading the energy throughout the asteroid's structure. If done precisely, the result could be the fragmentation of the body into thousands of small pieces, incapable of causing mass destruction. But of course, there's a catch to this solution. If the fragments hit Earth simultaneously, in close proximity, the combined atmospheric shock waves could be equally catastrophic. The key would be to hit the asteroid at least 1 or 2 million kilometers away, far enough away for the fragments to scatter through space and hit Earth at points so distant that they dissipate into luminous phenomena, transforming what would otherwise be the end of humanity into a harmless meteor shower. The problem is time. At 2 weeks, the window for maneuver is minimal. Even so, it would be the only real hope. What if we weren't talking about a stadium-sized asteroid, but rather a planet killer, a veritable colossus of ice and rock, tens of kilometers in diameter? In that case, the odds plummet. To move or fragment such a gigantic object would require hundreds of thousands of projectiles, or a combination of technologies we haven't yet mastered. This is where the story takes a different turn. Humanity, faced with such a formidable enemy, would have to improvise a last-ditch plan, combining the idea of penetrators with nuclear charges. The goal would be to tunnel into the comet or asteroid and detonate it inside, forcing its complete disintegration. It's not a perfect plan. It's a suicidal plan, with astronauts knowing they would never return, but perhaps it was the only alternative to save billions of lives. Imagine this final scenario. The countdown is just hours away from the collision. A single mission, with a single chance. The Penetrators launch and strike in succession, digging a 100-meter hole in the comet's frozen surface. The final projectile carries nuclear warheads of unimaginable power. It enters the tunnel, disappears into the darkness, and seconds later, the explosion occurs. The rock, which has traveled for millions of years through space, disintegrates into a cloud of incandescent fragments. The threat vanishes in a burst of light visible across Earth's night sky. The entire planet watches in silence as humanity face the impossible and survive. This is the power of a bold plan, of believing that even in the face of the abyss, there is still a chance. It's also a painful reminder we are not prepared. We rely on luck and improvisation when we could have ready strategies, stockpiled equipment, and tested technology. The story could have ended differently if the discovery had come just a little too late. And now, knowing that this risk is real, that invisible objects cross the space above us without warning, the inevitable question is, how would you react if you knew the world was ending in 2 weeks? Would you try to live normally? Would you chase dreams you've put off? Or would you believe that humanity still had the strength to fight the impossible? If this reflection resonated with you, leave a comment telling us what your first action would be when faced with news like this. Subscribe to the channel to see more content that explores the boundaries between science, the future, and survival. And leave a like so more people can access this discussion. Who knows? Perhaps thinking through these scenarios together is the first step toward being truly prepared when the unexpected happens.